In this nugget, you and I are going to take a look at IPv4 EIGRP through the eyes of Wireshark. Let's begin. I was at a customer site several months ago, and as I was talking with them about their topology, they told me that they were using EIGRP, and they almost kind of looked away in shame. I thought to myself, you know what? For a small network, one of the fastest converging routing protocols on the planet is EIGRP. And really, the only big negative about EIGRP is that it's proprietary to Cisco. And for many, that is a good enough reason to not use it all the time. It's also like the Good Shepherd routing protocol. Well, what do you mean, Keith, the Good Shepherd? Well, there's many stories about the Good Shepherd who will leave the flock and go after the one. Well, EIGRP is a routing protocol that if it had a route that it learned via EIGRP and it no longer knows about that route, EIGRP will start asking about it, wanting to find out if anyone else knows how to reach that network. So regarding EIGRP, it sends out layer 3 packets to the multicast address of 224.0.0.10. And for more details on the mapping of a layer 3 multicast address to an Ethernet MAC address, check out our nugget on IPv4 multicast. Another really cool thing about EIGRP is that it has its own protocol number. It's not using TCP, it's not using ICMP, it's not using UDP. It has its own protocol number of 88 in decimal. And every 5 seconds, it sends out hello messages. That allows EIGRP neighbors to make sure that the neighbor is still reachable. So what we get to do is we're going to lab up a simple topology. And as part of the Nugget Lab files, I have the pre-configs for routers 1, 2, 3, and 4. It has their IP addresses configured. And the base config that's available in the Nugget Lab files for these 4 routers is simply missing a routing protocol, which we'll go ahead and add. We'll also capture the traffic on one of the links right here between R2 and R3 so that we can analyze the details of what's going on regarding EIGRP through the eyes of Wireshark. One of the secrets I've discovered in working with practice labs is that if we have a very identifiable network that we can track and see being advertised via a routing protocol, it's a lot easier to tell what's going on. So let's create a loopback 0 interface on R4 with the address of 4.4.4.4. And then we'll make sure we advertise that as well as all of the interfaces that begin with 10 across our entire topology using EIGRP. So here on R4, we'll go into configuration mode. We'll create interface loopback 0, and we'll give it the IP address of 4.4.4.4, and we'll use a 32-bit mask. Next, let's create a routing process for EIGRP, and let's use autonomous system number 777. And then we'll add the network 4 into it. Any interface that has a 4 for the first octet is now participating and included in EIGRP. Let's also add the network statement to include the 10 network interfaces that are connected to R4. And that would be the Ethernet 1/2 interface and the FA00 interface. They both begin with 10, and this network statement brings them both in. And I really like the idea of baby steps. So if we wanted to verify that we've included all the interfaces here on R4, we could issue the command show IP EIGRP interface, press enter, and that will show us all of the interfaces that are currently participating as part of this EIGRP process. And the do command that I added allows me to issue this show command even though I happen to be in configuration mode, as opposed to being at privilege mode. We could also issue the command show IP protocols just to verify what routing protocols are running on this router. And this reveals that EIGRP autonomous system number 777 is running and that auto summarization is disabled. Now that's because I'm running currently iOS 15.x. Auto summarization is disabled by default. If you happen to be running iOS 12.x, you'd want to make sure you manually set the auto summarization to off. And even though it's off by default here, I want to demonstrate that as well with a no auto-summary, and we are now good to go for R4. Next, we're going to make a road trip over here to R3. And what I would like to do is we're going to take this interface right here on R3, and let's temporarily shut it down. We'll enable EIGRP on the router, and then once we have all of the routers configured, we can start our packet capture on this link between R2 and R3, and then we'll bring up the interface on R3. And that way we can see all the activity about the updates and so forth that are happening between R2 and R3 when a brand new neighbor comes on board. So on R3, we'll go into configuration mode, and for interface Ethernet 1/1, we'll simply go ahead and say shut down. Next, let's configure EIGRP for autonomous system 777. We'll include all interfaces that begin with 10 as the first octet, and we'll disable auto summary just for good measure. And mostly, I'm doing that so if you're following along, which I hope you are, and labbing this up on your own, if you happen to be running iOS 12.x, I want you to have good results, and that's why I'm including the no auto summary here as well. Next, we'll make a road trip over to R2, and on beautiful R2, we'll go into configuration mode. We'll bring up EIGRP Autonomous System 777. We'll include Network 10. We'll also turn off Auto Summary just to make sure it's off on R2. And last but not least, we'll go to R1 on the far left of our topology. We'll go into configuration mode. We'll enable EIGRP for Autonomous System 777. We'll use a network statement to include the 10 networks. We'll turn off Auto Summary, and now it's good to go. And we have a beautiful message that it has a neighborship already between itself and R2. Next, we're going to start the capture right here between R2 and R3. So inside of GNS3, we'll go ahead and click on this link between R2 and R3, and we'll start our Wireshark capture. So with a right click on the link, Start Capture, we have our choice of either interface, the one on R2 or R3, because they're both connected to that same segment. We'll grab R2's, click OK, and then we'll minimize Wireshark. We'll come back to that in just a moment. So this interface right here on R3 is currently disabled. It's in a shutdown state, so let's go ahead and bring it up while the capture is running. So we'll go to the right router, which is R3. Very important to get on the right router. And because we're already in configuration mode, we'll simply go into interface configuration mode for Ethernet 1/1, and we'll do a beautiful no shutdown. And based on this neighborship message, it looks like we now have a beautiful neighborship between R2 and R3. Let's verify here on R3 what EIGRP routes that we have learned from our neighbors R2 and R4. So the command I used is show IP route, and the EIGRP option simply says just show me EIGRP learned routes. So we've learned about the 444 network, that's the loopback over on R4. We've learned about the 10.11 subnet, that's right here, the 10.12 subnet, which is between R1 and R2, and the 10.44 subnet, which is over here hanging off of R4. And R3 is not reporting subnet 23 nor subnet 34 as being learned via EIGRP, and that's because those are directly connected networks that R3 is connected to. We can also issue a show IP EIGRP neighbors just to validate who our neighbors are. So R3 is saying, yeah, I know about R2 and I know about R4. And those are the respective IP addresses on R2 and R4 that are being shown here in the output of the show IP EIGRP neighbors command. Next, let's do this. Let's go over to R1. And here on R1, let's create a new loopback interface and give it the IP address of 1.1.1.1. And we'll also include that as part of EIGRP 777. And that way, as this new network comes up, R1 is going to advertise to R2, R2 is going to tell R3, R3 is going to tell R4, so that all the routers are going to know about the reachability to the 1.1.1.1 address space. And because we're capturing traffic between R2 and R3, we can see those updates. So here on R1, we're already in configuration mode, so let's create interface loopback 0, and we'll give it the IP address of 1.1.1.1, and because it's a loopback, we can go ahead and throw on a 32-bit mask. Now, even though that interface is up, it's not included as part of EIGRP because our current network statement only includes interfaces where the first octet is a 10. So let's add a network statement that will go ahead and include any interfaces that have the first octet of a 1. And we could verify that with a show IP EIGRP interface just to validate that loopback 0 is indeed participating as part of EIGRP 777. Now, how do we validate that R4 knows about the 1.1.1.1 network? And there's several ways. We could go over to R4 and do a show IP route or show IP route EIGRP, or from R4 we could try to ping 1.1.1.1, and if it works, we know it has reachability to that network. And another clever option is, while we're right here at R1, we could go ahead and ping, for example, 4.4.4.4, which is R4's loopback address. We've learned about the route to that network address space through EIGRP, but instead of just pinging it, we could also source our ping from 1.1.1.1. And that way, when we send our ping to 4444, if the replies come back and the ping is successful, we know that R4 has a route to 1.1.1.1 because it replied to our pings that we sourced from 1.1.1.1. So to implement the ping right here from R1, we'll do a ping 4.4.4.4, and we'll use the keyword source, and I'm going to source it from my loopback 0, which has that 1.1.1 address. And we have 5 out of 5. That's fantastic. And I use the do command here in front of the ping because I'm not in privileged or user mode, I'm in configuration mode. So the do simply allows me to issue the command without having to jump back to privileged mode. Now, for our next trick, which is kind of cruel, we're going to go ahead and remove interface loopback 0. So that network, that route, no longer is going to exist inside the topology. And the cool thing with EIGRP is that if all these neighbors are communicating with each other, they can figure that out in a very rapid period of time. compared to really dumb routing protocols like RIP version 1. So on R1, we're still in configuration mode. Let's go ahead and do a no interface loopback 0. That will remove the interface along with its IP address, and the route to 1.1.1.1 will no longer exist in the topology. And R2 is going to send a query saying, hey, do you know where 1.1.1.1 is? I'd like to know. So in our packet capture, I'm going to stop the capture of packets here. I'm also going to do that equivalent stop inside of GNS3. So in GNS3, we'll right-click on the link between R2 and R3, and we'll say stop capture. Let's also save this as part of the Nugget Lab files, and we'll call it IPv4 EIGRP. So this, along with the initial configs for the 4 routers and all the commands that I issued in this nugget, all 3 of those files will be available as part of the Nugget Lab files. And if we want to filter and just take a look at the EIGRP related traffic, we can use a display filter and simply type in EIGRP, press enter, and that will show us only the EIGRP traffic, which happens to be 327 out of the total 514. So initially, we didn't have R3's interface up for several minutes. However, R2 was sending out hello messages, and if we look at the timestamps, it was approximately every 5 seconds. It's sourcing it from its Ethernet IP address, and the destination is the multicast address of 224.0.0.10, which is used by EIGRP. And in the packet details pane, if we expand the layer 3 header information, we can see right here that in the IP header, it points to the next protocol, which is EIGRP, and there's our decimal 88. If we collapse that, and we open up the EIGRP payload information, and expand the parameters for EIGRP, it's showing us that this is a hello message that's being sent. Here's the autonomous system number, and here are the K values that are currently set on this router. And if 2 neighbors don't have the same K values, or they're not using the same autonomous system number, they won't become EIGRP neighbors because of the configuration differences. So that's frame number 2 from this capture. If we scroll down to packet number 22, this is the first hello message from R3 after we brought up its interface. Here in packet 31, we have R2 sharing its routes via EIGRP so that R3 can learn about those routes. Then if we scroll down to packet 236, this is just a moment after R1 introduced the 1.1.1.1 address space. And as a result, R2 learned about it, and this packet capture is showing the update here in packet 236, where R2 is advertising this route of 1.1.1.1 via EIGRP so that R3 can learn about it. And then once the network settles down, we have simply hello messages until the next change. And that next change is when we removed the 1.1.1 address space from the topology. And when we did, R2 in packet 467 sends out a query. So if we look at the details for packet 467, it shows it being a query. And the route that it's looking for is 1.1.1.1. In this nugget, we've added EIGRP to this topology and captured and analyzed some traffic between R2 and R3 to confirm some of the details regarding the protocol EIGRP on an IPv4 network. I have had a great time in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.